Alright, let's take a look at fractional indices, which is part of the GCSE Maths course. First of all, before we begin, let me just do a quick review on what indices are. Indices are basically powers. So it's when a number is put to the power of something. So for example, 5 to the power of 2, 6 to the power of 7, 5 cubed, 5 to the power of 4. These are all indices. More specifically, these numbers on top, they're sometimes also referred to as powers. These are what we call indices. So, in the previous video, I looked at negative indices, which is when we have 5 to the power of like negative 2. And we can simplify this to write it as 1 over 5 to the power of 2. Because we can think of 5 to the power of negative 2 as 5 to the power of 0 divided by 5 to the power of 2. Because remember, part of the rule of indices is that when you divide powers, you minus the powers, right? So it becomes 5 to the power of negative 2. When you multiply the powers, you add the powers. So 5 to the power of 0 is also can be written as 1, and below it would be 5 squared. That's where this comes from. We write 1, 5, and flip the sign, but that's where that is derived from. Okay, if you didn't watch the previous video, I highly recommend it because it kind of explains the important concepts of this video. So then, we have fractional indices now. Fractional indices, well, as you can guess, is when you have a fraction as the power of a number. You could also write this as in decimal form, so 5 to the power of 0.5. It's sometimes written like this on the exams as well. But more commonly, we'll use this as, that's what the name is, fractional indices. But this and 5 to the power of 0.5, as you know, you can convert fractions to decimals, right? So they mean the exact same thing. So then, what exactly are fractional indices then? Well, it's when you have a fraction as the indice, the power. But what do you do with it? So, I'll try to explain it like this. We have 5 to the power of half multiplied by 5 to the power of half. Now, what happens when you multiply? You add the powers, right? So you could simplify this as half. What's half times half? When you multiply numbers with powers, you add the powers, right? Sorry, I misspoke. Well, then half plus half makes 2 over 2, which is 5 to the power of 1, which is equal to 1. Now, I chose this very specific example because it's quite easy to understand the concept with this half as a power. When we have 2 of these, we can have 5. So it's 2 numbers, as you can see, 2 numbers that are exactly the same, right? These are the same numbers because they're both 5 to the power of a half. 2 numbers that multiply together that are the same, that make the number 5. What is that number? If you know, it's called a root. More specifically, in this case, it's a square root. So you could write this as 2 square root of 5 like this, but because the square root is the default, we write it as just square root 5. So what does this mean? In the previous video where I explained the basics of square roots, I explained that it's 2 numbers that multiply together to make the number below it. So the square root of 5 is 2 numbers that multiply together to make the number 5. So 5 to the power of a half is the square root of 5 because it's 2 numbers that multiply together to make the number 5. Let's go a bit deeper then. 5 to the power of a third. What do you think this is? Well, since this too symbolized, because look, 5 to the power of half times 5 to the power of half is 5 to the power of 1, right? So it's 2 numbers, 1 and 2. 5 to the power of 3, you could see this as 3 numbers just by seeing the 3 in the denominator. But you could also see it as 5 to the power of a third multiplied by 5 to the power of a third multiplied by a 5 to the power of a third gives us 5 to the power of 3 over 3, which is 5 to the power of 1, which is 5. So it's 3 numbers, 1, 2, and 3, that multiply together to make the number 5. Well, if you watch the previous video, you'll know that this would be the cube root of 5. Now, note, we do have to write the cube symbol at the top right corner now, top left corner, I mean, because it's not the default anymore. The square root is the default, so you can remove it, but now we need to add it. And by the way, you can't write it as 3 root 5 like this. This is not the same thing as this. This means 3 multiplied by root 5. This means 3 numbers that multiply together to make the number 5. All right, pretty simple, right? And let's dive a little bit deeper and let's make it a bit harder and more challenging. All right, 5 to the power of a quarter. You guys pretty much get the hang of it, right? So 5 to the power of a quarter, you could see it as 4 numbers that multiplied by looking at the denominator. But you could also see it as 5 to the power of a quarter multiplied by 5 to the power of a quarter multiplied by 5 to the power of a quarter multiplied by 5 to the power of a quarter. Remember, when you multiply, you add the indices, so that makes 5 to the power of 4 over 4, which is 5 to the power of 1, which is 5. So it is 4 numbers, 1, 2, 3, and 4, that multiply together to make the number 5. What number is that? As you can guess, it's the 4th root of 5. 4 numbers that multiply together to make the number 5. And the key thing is it needs to multiply with itself. It's not 4 different numbers. It's one number that multiplies 4 times to make the number 5. All right, then. Now we kind of get the pattern, right? So then what's 5 to the power of 1 to the 100? I'm not going to write this 100 times, but you guys pretty much get the pattern, right? This is, look at the denominator, it's 100. So it's 5 to the power of 100, 1 over 100, multiplied by 100 times, which is going to be the 100th root of the number 5. 5 numbers that multiply together to make the number below the square root. Then we can generalize this now. So if 5 is the number we have, 1 over n is the formula pretty much, where n can be any number. N equals any number. And 5 to the power of 1 over n is going to be equal to the nth root of 5. Whatever this n is, it's how many times the number multiplies. So the nth root of the number 5. We can even generalize this even further. So we could say x to the power of 1 over n is equal to the nth root of the number x. That is pretty much it for fractional indices. However, we have a catch. It's not really a catch, but it gets a little bit more challenging. What if the power is 5 to the power of 2/3? It's not a third anymore. We had this before, right? This was square root of 5, the cube root of 5 actually, sorry. 3 numbers that multiply together. So because we have a third, it's one number, right? Then would this be root 5? So it's still 3, so it should be 3 numbers. But this 2, what does a 2 mean? We have 2 of these, right? 2 of these 1/3, because 1/3 plus a third is 2/3. So it's probably 2 of these. So we could do this, and we could square this, can't we? Because 5 to the power of a third squared would give us the cube root of 5. But we have a squared now, right? So what does this mean? What would happen? Well, 5 to the power of a third squared would be, you just put this in your calculator, the cube root of 5, and you square the answer. It's 2 sets of these. So it's basically, that's the answer, the cube root of 5, which is roughly 2.92401 recurring. Something like that. There's an alternative method to think about this, though. Because we're squaring this, right? We have 2 sets of this cube root of 5. You could think of it like this. It's root of 5 squared. Sorry, not root of 5. It's 5 squared multiplied by a third. That would be 25 multiplied, 25 to the power of a third, which would be the cube root of 25, right? Because this goes back to the original thing here. 25 to the power of a third, I mean. This is the exact same thing as that. So because we're squaring this number, we have 5 to the power of 2/3, right? This is going to be equal to 5 squared, because we have 2 sets of these, multiplied to the power of a third. Because it's 5 squared, 25 to the power of a third, which is the cube root of 25, which is 2.924, something like that, which is the equal to this. So it's roughly the same method as the previous one.